Hi, Michelle Glass here. Welcome back to another episode in Chapter 26, Lecture 26 series, and we are ready to talk about the nephron. Remember, the nephron is the smallest functional unit of the kidney. It's found extensively through the renal cortex and the renal medulla. It is the location of urine production. Remember that nephrons can come in two types depending on their location. So if they're found exclusively in the renal cortex, we call that a cortical nephron. If it is found in both the cortex and extending into the renal medulla, which remember is consisting of those pyramids, then it's called a juxtamedullary nephron, where that term juxta means close to, and then of course medulla. So we're going to be looking at our nephron as it would be like all stretched out. So this is not actually how it looks anatomically, but more studying the structures in terms of the order of the flow of material. And then we'll have a video presentation dedicated to each one of these sections. So this is like our kind of super basic introduction to the nephron. Okay, so let's start with what's called the renal corpuscle. The renal corpuscle consists of the glomerular capsule. The glomerular capsule is consisting of the kidney tissue. And then embedded in the capsule, you have your glomerulus, which is your capillary. Let me see if I can make that bigger for you. I hope you can see that a little bit better. When we're looking at the glomerulus or that capillary bed, notice that you have an afferent arteriole bringing the blood in to the capillary, and then you have an efferent arteriole taking the blood away from the capillary. So remember, afferent or afferent means coming in, efferent or efferent means exiting or leaving. Notice there's a difference in the diameter. Your afferent arteriole is much bigger opening, and then the efferent arteriole is much smaller. So what this means is you're allowing a lot of blood to move into the glomerulus, but then you're kind of slowing it down as it's exiting, which actually builds blood pressure inside the glomerulus. So we will see and talk about again that the glomerular blood pressure is higher than the systemic blood pressure. And this will be important because the job here of our glomerular capsule is filtration. Filtration is just a movement, this exit of material from the blood into that capsular space. Again, the term renal corpuscle is referring to both components, the glomerulus as well as the glomerular capsule. Okay, from here, this fluid is going to be called filtrate. It's going to be moving into our kidney tubule. And so once it goes into our kidney tubule, we will be calling it tubular fluid. The first tube that the fluid moves into is called the proximal convoluted, see if we can make that one bigger. Proximal convoluted tubule. So proximal because it's closest to this capsule, meaning the filtrate is brand new and this is its first stop in the proximal convoluted tubule. The term convoluted, my definition of that is twisty-turny. So we're going to see that there's lots of bends and kinks in this tube, and then of course tubule is just meaning tiny tube. The job of the proximal convoluted tubule will be reabsorption. Reabsorption means leaving the nephron and ultimately moving back into the bloodstream. So we're going to return water, and we're going to return ions, and we're going to return nutrients back to the bloodstream. Remember, one of the jobs of the kidney is to conserve nutrients, and so we're seeing that here. This has to happen because filtration is not very selective. If the molecules can fit through the openings, they will leave that glomerulus. And so there's not a lot of specificity to a filtration process. From there, your fluid is going to move into what's called the nephron loop, or the loop of Henle. Notice you have a descending limb and then an ascending limb. So you have fluid moving down and then fluid moving up. And we'll see different functions happening on each one of these limbs of the loop. In the descending limb, we're going to get reabsorption of water. So that means water is leaving the nephron and moving back into the bloodstream. On the ascending limb, we're going to see reabsorption of sodium and chloride ions. And so we'll be talking about this again as we go through and look at the nephron loop in more detail. So we're going to talk about the nephron loop as having this overall job as regulating the osmolarity. And from there, material moves into the distal convoluted tubule. So it's distal because this is the furthest part the fluid is getting away from that glomerular capsule. It's convoluted because it's also twisty-turny, just like the proximal convoluted tubule. And again, we're still a little tube inside of the kidney. Now, what we're going to see is that that distal convoluted tubule actually folds over so that it's going to be close to that glomerular capsule anatomically. But from a physiological perspective, this fluid is pretty far away from that initial filtration. In the distal convoluted tubule, we'll see reabsorption of water and ions, and also secretion of waste. So that means waste product is going to move from the blood into the distal convoluted tubule. With both of those little tubes, I've highlighted the beginning letters. So we can abbreviate distal convoluted tubule DCT, and we can abbreviate the proximal convoluted tubule as the PCT. Going back to the DCT, from this we're going to see fluid moving into what's called the collecting duct, and it's at this point that we're going to call it urine. You will still see occasionally some reabsorption of water happening here. This is artwork taken from Wikipedia. So we have a Creative Commons license for this, so I can show this to you. This is a little bit different, maybe from the artwork in your textbook, so you can reference either one. In this case, it's showing you more the anatomical formation of your nephron. So notice how twisty and turny our convoluted tubules are. Notice that the proximal convoluted tubule and the distal convoluted tubule are close in proximity, close anatomically to that glomerular capsule, or what can also be called the Bowman's capsule. But remember, they're named based on the order of how the fluid gets there. So it starts at the glomerular capsule or Bowman's capsule, moves next to the proximal convoluted tubule, down the descending limb of the nephron loop or the loop of Henle, up the ascending limb of the nephron loop, and then to the distal convoluted tubule. From there, it makes its way to the collecting duct. The collecting duct then is going to be dumping into what's called the papillary duct. So now we can add to that description of the flow of urine. So it's going to start as filtrate in the glomerular capsule, move next as tubular fluid to the proximal convoluted tubule, descending limb of Henle, ascending limb of Henle, distal convoluted tubule, collecting duct, papillary duct, and then we get to what we already know: minor calyx, major calyx, renal pelvis, ureter, bladder, urethra, and out of the body. So that's it for now.